question. Question reads, alright, so I want you to write the introductory statement plus this table from the board, and then I'm going to erase it and continue the different parts, alright? Alright, so to determine the molar concentration of a solution of sulfuric acid, 25 cm³ of potassium hydroxide solution of concentrated 0.4 m. What does capital M there stand for? What's the unit?
Mole.
Moles per dm³. Right, so when we see a capital M here, Mr. Harding, it means the unit in moles per dm³. Alright, that's what we mean by molar concentration, a capital M. Right? So So potassium hydroxide solution of concentrated 0.4 molar was measured in a pipette and run into a conical flask, right? So the base potassium hydroxide was 25 cm using the pipette and put in the conical flask, put on the disc, right? Then in the burette, the sulfuric acid was placed in the burette and the titration was performed. The results of the rough and the first and second titration is shown in the table, right? So remember that when we read in the burette, we normally would have an initial reading, can be 0, but it don't have to be 0, right? Initial reading here is 0. We gradually drop the sulfuric acid in this case in the conical flask from the burette until the indicator changes color. And the indicator that we could use here is like phenolphthalein, which is normally colorless, is pink in acid, colorless in base. Alright, so if for example we had this, the phenolphthalein in the base, the potassium hydroxide, it would be colorless, but as soon as we reach the end point, when the titration finished, then it would just suddenly change to pink. So that's an indicator we could use to determine the volume of the acid used in this case, which is the sulfuric acid, right? Then we do it a second time. So for example, the second time we would start with 20.3 as the initial volume, and then we titrate it until we reach 40 cm3, right? Then we would refill the burette again at 0, and then we use 20 in this occasion. Alright?
The sulfuric acid is the unknown.
In terms of the concentration, yes. It's the unknown.
And the
potassium hydroxide, we know about the volume and the concentration.
The concentration is 0.4
moles per dm cube. Because the capital M in molar concentration.
And the volume?
The volume of what? The potassium hydroxide? Yeah. 25 cm3.
So what's the volume of the
acid?
The acid.
That's what we're going to determine from this table here.
Okay.
Alright? So before I erase this, let's just calculate the volume of the sulfuric acid used. Alright? Because the sulfuric acid was placed in a burette and the titration was performed. The results are given below in the table, right? Which is this table. Alright, so for the rough titration, what would be the volume of sulfuric acid used in this case?
20.1.
20.1. 20?
Yes, sir.
Here?
20.
Good. Alright, so it's safe to say from this, using the two accurate titration and not the rough, that the volume of sulfuric acid that is required to neutralize the potassium hydroxide is 20 cm3.
I don't know what it comes to.
You just subtract the final minus the initial. Yes.
Oh, okay.
Following?
Yeah. So that would be the amount we left back in the little tube.
No, the final volume is what left back in the burette. Alright, A. Answer for this is 20 cm3, right? So basically for this is using titration 1 and 2, right? We're going to see that the final volume used equal to the final burette reading minus the initial should be equal, and then we could use it an average, right? So in this case, 40.3 minus 20.3 is equal to 20. So that's for titration 1. And for titration 2, it's 20 minus 0 is equal to 20 cm cube. That is why we'll get this as the answer. You have to show that in the exam, right? Because you'll probably get marks to complete this table as well. Right? A balance. So it is potassium hydroxide. What's the formula for potassium hydroxide? KOH, and it's aqueous. Plus, what's the formula for sulfuric acid? H2SO4, AQ. What do we produce? Salt and water. So normally salt is the anion from the acid and the cation from the base.
K.
Right? So it's gonna be
KSO4.
yes, but this K is +1, SO4 is -2. So what would be the formula for potassium sulfate?
K2. What is it? K minus.
K is +1.
+1.
Group 1 metal.
And
Sulfate is a complex anion, but the overall charge is -2.
so the K2 then.
Yes? What else?
K2SO4.
Good. Alright?
Solid.
No. Aqueous.
No,
Why?
no, man, say, man's a solid, sir.
You answer solid?
No, sir, I'm saying it's a good answer.
Oh, it's okay. Alright, let's go over. Plus water. Right, so remember that an acid plus an alkali will produce salt and water. Alright? Now, how do we balance this equation? Or is this equation balanced?
Well, no, we have two.
We need a 2 here.
Yeah.
2 potassium here, so we have to put that 2 here, right?
And
What about the water?
The
We have 2 here and 2, that's 4 hydrogen.
I have two. No, hold on. Have one hydrogen that over there, sir. One H and two H over there, sir.
You have 2 hydrogens here.
Yeah,
and have
one hydrogen. Oh,
times
so the
2.
two.
So that'll be 4.
So you have.
And then you have 2 oxygen. So I'm talking everything different from the salt. Because the sulfate, SO4 is going to stay the same. It's just 1 mole of sulfate over here and 1 over there.
So how much oxygen?
2
Of 2 oxygen.
and 4 hydrogen. So how do we balance the water over there?
The water. Hold on. The water.
That number needs to go in front of the water for it to be balanced.
But then two. How much hydrogen? 2 hydrogen over here, sir?
It's 2,
3,
4,
4.
and 2, 4.
That's an 8.
2 plus 2 is 4 overall. So it's 2 here
Okay.
plus this 2, like
Which
4.
is 4.
So put that 2 here,
The 2
it's
here.
4 hydrogen, right?
Divide the 2 by the 4.
And then this is 2 oxygen here, 2 oxygen. Alright? So that's the balance equation. So the formulas for the reactants and the products are correct.
So the oxygen in
Physical states are correct.
the,
And the equation is balanced.
for the oxide. Oh, that's an oxide.
Hydroxide.
The
OH is
hydroxide.
hydroxide. Oxide is just O.
Oh, so you don't check that O.
In this here, yeah, this is the 2, the 2 from the oxygen. Which is gonna be over here. Yeah man, because remember now.
Yeah.
And the equation is
Yeah, man.
2
Yeah.
Good. Alright. Moles of potassium hydroxide used in the titration. That's part C. potassium hydroxide used in. Alright, so you have to calculate moles. I remember that when we come on to titration, we need to know about the concentration, volume, and moles. These are the three quantities that we are interchanging. Alright? So what do we know? So here they say calculate the number of moles. So we know definitely that this is unknown. So it simply means that if the number of moles is unknown, we must know the concentration and the volume. Right? What's the concentration of potassium hydroxide from the question? 0.4 molar, which is the same thing. It's a molar concentration. So this is the same thing as 0.4 moles per dm cube, or moles per 1000 cm cube. See? Same thing. Alright? What's the volume?
What was the volume?
Look at the question.
You never get right.
Check your phone.
25
cm cube. This statement here, we know that 0.4 moles of KOH is in 1000 cm cube. Okay? Therefore, X moles of KOH is in how much? You're asking for? 25 cm cube. Right? So X is equal to 25 times 0.4 divided by 1000. What's the answer here? Moles. Remember that this is
0.01.
0.01.
Yes, sir.
Right, so 0.01 moles of KOH using the titration. Alright, you get the answer. Alright, so part B, use the balance equation to determine the mole ratio between potassium hydroxide and sulfuric acid.
2 to 1, sir.
So it is 2 KOH to 1 H2SO4, right? It is 2 to 1. Right? Based on the balance equation, it was 2 moles of potassium hydroxide to 1 moles of sulfuric acid. Alright? So part E, calculate the number of moles of sulfuric acid that reacted. This is part E. So how do we solve this aspect? Any suggestion? How do we calculate the number of moles of sulfuric acid that's reacted? I would just calculate the number of moles of potassium hydroxide. So since KOH to 1.
So you divide, say.
Good. Therefore, 0. What was it? The moles of this again? 0.01.
Yes, sir.
Equivalent to X moles of H2SO4.
If you get the balance equation wrong, sir, you basically get D and E wrong as well.
Yes. But sometimes in the examiner might use their discretion. But you're not going to get full marks, so. Alright? Because you're going to get some weird answer anyway. Alright? No. It simply means that the ratio 2 to 1, so it simply means that the number of moles of potassium hydroxide will be 2 times that the number of moles of sulfuric acid. Alright? So this, therefore, the moles of H2SO4 is going to be equal to 0.01 divided by 2.
0.005.
0.005. Alright. And then finally calculate the molar concentration of sulfuric acid. Alright, so remember that must have concentration, volume, and moles. Alright, these are the 3 quantities that we need. At all times when we are doing the neutralization, we have to have these 3 quantities, right? Sometimes we can use mass, molar mass, and moles as well, depending if you want to move from the molar concentration to the mass concentration. Those 3 quantities will come into play as well: the mole, the mass, and the molar mass. But in this case, they were strictly talking about molar concentration, so that molar concentration is capital M, or the concentration in moles per dm cube. Alright? So the concentration is what is unknown, right? The volume, what's the volume of sulfuric acid?
35.
Cut the question, Mr. Harden, and stop guessing.
You're the question, I remember. And the volume.
That's the one from the table.
Yeah.
I think it was part A was what is the volume of sulfuric acid needed to neutralize 25 cm3 of KOH. What was the answer from part A?
20.
Good. This is 20 cm3. Right? And what's the what number of moles of sulfuric acid that was used?
0.005.
Right? Right. So what we can say here is that 0.005 moles of H2SO4 is in 1000 cm3 of solution. No, sorry, it's in 25. Remember? It's in 20.
20.
Yeah, thanks. Why is this statement? We can make that statement because we calculated the number of moles of sulfuric acid using the titration, and we know the volume. That's why we can make this statement here. Alright?
Yeah,
therefore, to get the concentration is just basically asking how many moles is in 1000 cm3 of that solution. Right? So it is X moles of H2SO4 is in 1000 cm. We just stick to cross multiply here.
Cross multiply.
And you always get the answer. So if it's this, so it's gonna be this times this divided by 20. Alright? So it's 1000 times 0.005 divided by 20. What's the answer here?
So that's 5 divided by 20.
Oh, we don't have a calculator for the test today. Release your phone. Yes?
2.5.
2.5
Yes, sir.
moles Radium cube.